Safety procedures in laboratory. Make sure to follow all the instructions given. Wear a safety goggle and a glove. Do not eat or drink in lab. If accident occurred, quickly report it to the person in charge. Make sure to leave the lab clean after doing the experiment. Make sure to turn off the light, tap water, and fan after you are done using the lab. Next, the objective of the slump test is to determine the workability of freshly mixed concrete. The slump test is the most well-known and widely used test method to characterize the workability of fresh concrete.
Next, theory. The slump test is the most well-known and widely used test method to characterize the workability of fresh concrete. The inexpensive test, which measures consistency, is used on job site to determine rapidly whether a concrete batch should be accepted or rejected. Workability means the ease with which concrete can be moved and placed in forms without segregation. Meanwhile, consistency is a measure of the wetness of the concrete mixture, which commonly evaluated in terms of slump. Example, the wetter the mixture, the higher the slump. The heat of the concrete mix after being placed in the slump cone differs from one sample to another. Samples with lower heats are generally used in construction, while samples with the little slump are commonly used to construct roadways and pavements. Change in the value of slump obtained during a job may indicate change in materials, in the water content, or in the proportions of the mixture.
Next, the materials are cement, sand, fine aggregate, granite stone, coarse aggregate, and tap water. Next, the apparatus are standard slump cone, scoop or trowel, steel tamping rod, steel ruler, slump plate, steel float, weighing scale, and sampling tray for concrete mixing. Next, the virtual lab for slump test. Objective for this virtual lab is to determine the workability of concrete mix. The needed apparatus are slump cone, tamping rod, trowel, measuring jar, weighing scale, and others. Next, find the volume of the cone from its dimension given by measuring its height and diameter. Height for the bottom cone is 60 cm and radius is 10 cm. Meanwhile, height for the top cone is 30 cm and radius is 5 cm. So, we can find the volume of slump cone with the formula given 1/3 by pi by r square by h minus 1/3 pi by radius square by height, which is the bottom cone minus by top cone. So, the volume of slump cone is 5.489 exponent 10 -3 meter cube. Next, difference in radius of the slump cone from bottom to top is 5 cm. Next, step 2. Measure required quantity of water, coarse, fine aggregate, and cement based on mix design. Mix proportion is 1 to 2.7 to 4.2. Water cement ratio assumed is 0.43. Cement content is equal to cement divided by cement plus coarse aggregate plus fine aggregate multiplied by density by volume by 1.52. So, cement content is 1.6 kilogram. Next, Quantity of fine aggregate is equal to fine aggregate divided by cement plus coarse aggregate plus fine aggregate multiplied by density by volume by 1.52. So, the quantity of fine aggregate is equal to 4.3 kg. Next, quantity of coarse aggregate is equal to coarse aggregate divided by cement plus coarse aggregate plus fine aggregate multiplied by density by volume by 1.52. So, the quantity of coarse aggregate is 6.7 kg. Next is water content. Water content is 0.43 liters multiplied by cement content. So, the total of water content is 0.67 liter. Step 2. Measure required quantity of water, coarse, fine aggregate, and cement based on mixed design. The next step is dry, mix the material properly, which is mix the fine aggregate, coarse aggregate, and cement. Step 4. Add measured quantity of water. Mix it thoroughly and uniformly. Next, fill the mold in 4 layers. Each layer is tamped 25 times by a tamping rod. Then, remove extra concrete with the trowel and tamping rod.
Procedure. The cone was cleaned. It was dampened with water and placed on the slump plate. The slump plate should be clean, firm, level, and non-absorbent. A sample concrete mixture 1 to 4 was collected. For concrete mixture, 5 kg of cement was used. Stood firmly on the foot pieces and filled 1/3 the volume of the cone with the sample. The concrete was compacted by rodding 25 times. It was filled up to 2/3 and again rolled 25 times, just into the top of the first layer. Filled to overflowing, rodding again, this time just into the top of the second layer. Top up the cone till it overflowed. The surface was leveled off with the steel rod using a rolling action. Any concrete formed around the base and top of the cone was cleaned, pushed down on the handles and steps of the foot pieces. The cone was carefully lifted straight up, making sure not to move the sample. The cone was turned upside down and the rod was placed across the turned cone. The entire slump was measured and recorded. If shear collapse, the test must be repeated. If slump still happen, record the slump and type of slump. All procedure above was repeated using different water and cement ratio. So this is the result.
This is a discussion of the factors affecting concrete workability. A. Low water-cement ratio. The workability of concrete is reduced when the water-cement ratio is low. This is due to a lack of water to properly mix the concoctions. It will make the mixture rough, tough to separate, and difficult to finish. B. High coarse aggregate content. The workability of the cement will be low if the mixture contains a large proportion of coarse material. As a result, the concrete will be uneconomical, rough, and water permeable. C. High cement content. A high cement concentration results in a cement with a good workability. The more cement utilized, the more grout may be used to cover the surface of the aggregate that fill the space between them. This will aid in the reduction of aggregate friction and the smooth flow of aggregates, improving the mixing, transporting, pouring, and compacting of concrete. The conclusions I got from running this experiment is that the concrete slump of 1/2/4 result in as a kind of highly workable concrete. This is good ratio for creating concrete because it makes concrete smooth, strong, and easy to use. However, a concrete slump ratio of 1/3/9 results in moderate concrete workability. The optimal water per cement equals 0.55 minus 0.65. Concrete is available but is more difficult to handle and apply.